Hey everyone, welcome back to the channel. Today we are continuing with Module 3 of our Machine Learning series. In this video, we will explore the world of supervised learning by discussing 5 powerful algorithms: linear regression, logistic regression, decision trees, random forests, support vector machines, and k-nearest neighbors. We'll go over their concepts, implementation, and evaluation with sample code, real-world examples, and line-by-line explanations. By the end, you'll have a clear understanding of how these algorithms work and when to apply them. We'll start with linear regression, one of the simplest yet most effective algorithms for predicting continuous values based on input data. Linear regression attempts to model the relationship between a dependent variable y and one or more independent variables x using a straight line. It predicts outcomes based on the linear relationship between the variables. Step 1: data creation. We create sample data x and y, where x is the independent variable and y is the dependent variable. Step 2: splitting data. We split the data into training and testing sets to evaluate our model later. Step 3: training the model. We use the linear regression model from sklearn to train it on the data. Step 4: making predictions. After training, we predict the outcomes for the test set. Evaluation. We calculate the mean squared error, MSE, which measures the difference between actual and predicted values. Now let's move on to logistic regression, which is perfect for binary classification tasks where the output can only be one of two categories. Logistic regression predicts probabilities for binary outcomes, typically between 0 and 1. It is widely used in classification tasks like spam detection, fraud detection, and medical diagnoses. Step 1: data preparation. We load the iris dataset and simplify it to a binary classification problem where the target is class 0. Step 2: splitting data. We split the data into training and testing sets to evaluate the model's performance. Step 3: training the model. We use the logistic regression model to train on the dataset. Step 4: making predictions. The trained model predicts class labels for the test data. Step 5: evaluating the model. We evaluate the model's accuracy using accuracy score to measure how many predictions were correct. Let's look at decision trees, which are powerful algorithms used for both classification and regression tasks. Decision trees split data into smaller subsets based on feature values, creating a tree-like structure where each internal node represents a feature and each leaf node represents an outcome. The goal is to create branches that lead to the correct prediction or classification. Step 1: loading dataset. We load the iris dataset and split it into training and testing sets. Step 2: training the model. We use the decision tree classifier to train on the data. Step 3: making predictions. The trained model predicts the class for the test data. Random forests improve upon decision trees by creating multiple trees and averaging their predictions to reduce overfitting and improve accuracy. A random forest is an ensemble of multiple decision trees, where each tree is trained on a random subset of the data. The final prediction is based on the majority vote from all the trees. Random forest model. We use the random forest classifier with 100 decision trees. Step 1: training the model. The model is trained on the training data. Step 2: making predictions. The model predicts the class for the test data based on the majority vote of all trees. Now, let's move on to support vector machines, SVM, an algorithm that works well for both classification and regression problems. SVM works by finding a hyperplane that best separates data points into different classes. It is effective in high-dimensional spaces and can handle both linear and nonlinear data. SVM model. We use an SVC with a linear kernel to train the model. Step 1. Training the model. The model is trained on the training data to find the optimal hyperplane. Step 2. Making predictions. The model predicts class labels for the test data. Finally, we'll wrap up with k-nearest neighbors, KNN, a simple algorithm that classifies data points based on the nearest neighbors. KNN predicts the label of a new data point by looking at the labels of its k-nearest neighbors and using the majority vote. KNN model. We use kneighbors classifier with 3 neighbors to classify the data. Step 1. Training the model. The model is trained on the training data. Step 2. Making predictions. The model predicts class labels for the test data based on the majority vote of its nearest neighbors. In this tutorial, we dive deep into supervised learning and explore 5 of the most popular machine learning algorithms. Linear regression for predicting continuous values. Logistic regression for binary classification tasks. Decision trees for classification and regression by splitting data based on feature values. Random forests, an ensemble method of decision trees that improves performance. Support vector machines, SVM, which finds a hyperplane to separate classes. K-nearest neighbors, KNN, a simple algorithm that classifies data based on the nearest neighbors. For each algorithm, we explained the core concepts, provided Python code examples, walked through line-by-line explanations, and discussed how to evaluate the model's performance.